Okay, on to you, Chuha.
Yep. Hi everyone. This is Chu-Hua Huang from PNNL. Today I'm going to talk about the use case aggregate protection modeling and evaluation of dynamic composite loads using the TND dynamic code simulation. So in previous use case presentation by Surik from ANL, he already talked about many technical aspects of TND dynamic code simulation. So here for that part, I will not to be uh, repeat again. So I will more focus on the requirements of from this specific use case for HELICS, and as well as my experience that I learned when I developed this use case. So a kind of a brief overview about this use case. So what we are trying to do here is to provide a detailed individual load response, including the protection actions in the distribution side at the feeder level to the force in the transmission system in order to derive the aggregate protection models and evaluate the performance of the composite load model. For example, what you see here, the CMP-80WG, which is the default composite load model using in Western Interconnection of the United States, as well as many utility in the Eastern Connection. This will be helped to fill the gap of existing lack of a detailed measurement and knowledge about how the protection actually works at this individual low level in order to do this kind of aggregation. And as you will see, so this case will require the TND dynamic code simulation capability in order to capture both the load as well as the force. And here, just to recap, the HELICS state machine, like the different stage that you will be involved when using HELICS for the code simulation. And it's starting from creation and initialization stage, and as well as once you pass your initialization, you get into your time step basic iteration, which is execution. You see it here, and then once you reach the end, you will be queued the order factory and terminate. So with that, this is the requirement from this particular use case. So if you, as you can see here, it covers a wide spectrum that's designed for the design spectrum of HELICS, as well as many capabilities. Particularly for the initialization, we will using path load, which is will not involve any time step, but it will require the iteration. And once we have this converged power flow for both transmission and distribution, we will enter into the execution stage. And during the execution stage, we will have iterations for each time steps, which makes sure that the convergence of the transmission distribution system at the boundary. And until we get to the end of this simulation, and we will keep it federally. So, and one thing I would like to mention is, since Interfaces is a Java-based program, so we will be using Java API for in the transmission side, but for the distribution for the GoodLabD, which is using the C and C# API. Here's some more details about the implementations. So I would say the current form of implementation, as you can see in the picture below, regarding the data exchange, is the most simplest one I can envision or imagine. That the transmission side will be sharing the boundary bus voltage to the distribution, and the GridLabD will be calculate the total load at a substation level and then feedback to the interfaces. So this is, I would say, at this stage is mainly for testing HELICS, and PNL, actually, the PNL team have been study and compare several potential interface techniques, including different forms of equivalent data for TND code simulation, as well as different interaction screens, which has been covered by Surik in his previous discussion. So I will not go into detail about these two technical details. But I'll mention that we have been studied this, and then we have been write a paper and has been maybe presented in the coming general meetings. And we are going to implement some other forms in the next phase of this use case. So the test case, we have been testing the development with a IEEE 39 bus system coupled with a taxonomy feeder, which is a general feeder for commercial loads, which has have a high percentage of the loads are representing the commercial buildings. And in this case, we have about 7 commercial buildings, which including 1 large office, 5 small office, as well 1 hotel. And in total, in the feeder side, we have 27 induction motors that attach to the feeder, and we apply the 4 surrounding and near to the bus 18 in the transmission site, and then we will observe how the protections equipped with those attached to those induction motors responds to that fault. So here's some very high-level overview of the results. So we able to capture how the chip and reconnection time of different classes of induction motors. This class is consistent with existing composite load models, the classification. So the point here is that you will observe different types of motor definitely have very different response. And one important comparison with existing composite load model is how the protection at aggregated level will be respond. So here I'm showing you the normalized fraction of those non-shifted fraction of the 3-phase induction motors, and then compare the results obtained from the existing composite load model with the default data. So you will see both at the timing as well as the level of the chipping, they are quite different for both these 3-type induction motors, and the main difference is very obvious, particularly for the motor MC type. So this is a kind of a initial results, and then what I'm going to focus on in the next few minutes is we sharing some of this experience I learned, or as kind of a feedback to Phil and other developers of HELICS. So one thing I observe is that now we using a second as a unit for specifying the time steps, but internally I found HELICS using nanoseconds, right? And then what I observe here is that so here is a capture. So when it's a HELICS time as well as the time that was in current time step, and HELICS time is the time approved by HELICS. So you will see at after we convert it from double to integers, you will see that the original 0.005 seconds becomes 49995, which is a little bit different numerically from the HELICS approved time. So for this, we have to kind of using a torrent for our feather rate in order to check the time and ensure that the approved time is consistent with what we are requesting. So I guess the question becomes, this means there will be every feather rate we have a kind of a torrent, but the challenge is how to make sure that torrents are consistent among many of these feather rates. Maybe if we have some inputs after this presentation. And the other time importance point would be when we're doing the early development, we usually a lot of debugging. And when we try to using the debugging for example, using the HELICS player, but during the initialization stage, the feather rate always get the 0 value from the HELICS player. So here's an example that, for example, I play in this this data to my feather rate, but at the time 0, it's always get at the initialization stage always get the 0. So my question becomes, how can we use HELICS player for debugging the initialization stage, not for the execution stage? And here's some more experience. So I observed that when in some cases, when both T and D feather rates enter the initialization stage, both will get stuck at feather rate enter initialization mode. So this is, I'm not sure it's particularly for the Java API or would be some common problem for other API languages. And occasionally we observe some loss of connections with the server, but without any meaningful reasons. It just got lost the connection. So I'm not sure whether it's our internet issue or what. But we are only do this texting with only one using one server. So we are not like communicate between different PC or cores. And here's some experience I want to share for those use cases with GoodLabD. So for GoodLabD to use the Helix in the delta mode connection, in the delta mode, so you will need to set this particular settings to be enable sub-second module to be true for using the Helix in the delta mode. And in order to force the GoodLabD into delta mode at the time step 0, you will need, most likely you will need a player in order to, otherwise GoodLabD will be in the normal operation mode. And the last would be 2 questions that for developers to consider. So I'm thinking about if 2 independent federates having the same sub or pub sequence would be causing any conflicting. So is it any mechanisms in the development that to avoid such kind of a issue? And the other would be like, is it possible to do auto conversion of data types, for example, from complex to string or double the integer, this kind. So this will be help the development process of the use case, some of the use case, because it may not be always the users clear about the outputs of some others, but they were more clear about what they need as input. And also, is there any mechanism for detecting the data type mismatch if there was the mismatch that was not allowed it, so and we let the users to know about this mismatch. So this is all the experience I would like to share. Thank you. If you have any questions, please let me know.
So are there questions or comments specifically from developers?
If you want to go back to the questions you had, I think I can address most of them.
Okay, thanks.
Let's start on the last page. Those are a little easier.
Okay.
In the initialization stage, if you have a use case that gets stuck, let me know. That shouldn't happen, particularly in the newest version. The lost server connections, often it's where it can't connect to the broker for some reason, like the port is already being used by another one. This happens a lot if you're kind of starting and restarting the tests sometimes.
Okay.
And for those 2 questions you have there, that shouldn't happen. So if 2 federates, if they have the same pub-sub sequence and they are granted the same time, they will just get the values at the next time step. So they shouldn't lock each other.
So here is especially like both have the same time step. For example, I'm looking at like 1 second, for example, each of this, and they are trying to subscribe the value of 1 second.
So unless you specify one as ahead of the other, they're both going to be granted the same time, and then they'll both get the updates that the other one published at the previous time step.
I see.
If you wanted to iterate on that, then at the next iteration, they will get the values at the same time step.
Okay, so that means it will be subscribed when what they subscribe to is actually the previous time step, right? It's
right.
Now okay.
And the automatic conversion of data types is already built in. So the APIs you're using, there's a publish string and publish double and publish complex. Those will all work and translate to whatever you specified it as, and on the other end you can use any of those functions and it will translate automatically.
Okay, that's good.
And if you go back a slide, the numerical tolerance is kind of an interesting question, particularly on the APIs. Internal to Griddyne, it uses long integer times.
Mm-hmm.
So that's not really an issue internal to Helix. But to get out the interface, particularly the C API and by extension the Java APIs, it all gets translated to doubles, in which case you may experience some numerical issues on the interface level. If you know of a way to get around that, we're open to suggestions on updating that to make it less of an issue. But it's a issue with the particular interface you're using as opposed to internal to Helix.
Okay. Yeah, I would double check this with Andy to see whether we can work around this easily or nicely.
Yeah. And as far as the player, if you give it a negative time, it'll spit that out during the initialization period.
Mm-hmm.
You can also use a set default on the subscriber, in which case that'll be the initial value it gets if it hasn't received an update.
So you mean if the for example the line number 2, if I don't set 0 but set for example minus 0.1, it will be using as the initialization?
Yeah, it'll send that during the initialization stage.
Okay. Actually, I have been trying this, but I'm not sure whether it's because particular the Java API issue or not. I will double check, but my earliest experience trying this yesterday was still not, successful.
Okay, I will double check that. I thought I had a test case that checked that, but I will check it again.
Okay.
We're also working on some ways to do iterative times through the player, but that's probably a little bit down the road.
Okay, thanks.
Any other questions? Okay, I had a quick question. Juha, if you can go to the next slide.
Okay.
The case with GridLabD, where you have to use a player to force GridLabD into delta mode. The whole idea for that is whether Helix is able to take a federate or accept if a federate changes its time step during simulation. So from a 1 second time step during simulation, if it can go to a sub-second time step. Is that enabled in Helix already? Because that's a function that we are using currently from Phoenix at this point, and would be good to have that in Helix as well.
So I just wanted to make sure that I get it correctly. So you mean is the mechanism to transition from the normal operation mode, for example, 1 second time step to sub-second mode? Is it already implemented? Are you asking this?
Yeah, I'm asking if that's implemented in Helix.
Yes, Helix implemented. Yeah, Helix is already have these capabilities for the transition. So you need to specify when you're going to start your initialization mode and when you. So this is actually related to the mode change here. So you have initialization and you have execution. So all those in before are in the initialization stage. This is my understanding.
So,
and the last email from exchange with Phil and Andy, and he suggests that we may using not the time delta but period in order to, if you want to change your time steps, during the execution stage. Phil, is it that what you recommended?
Yeah, I think in your use case, you're wanting to do periodic sampling, in which case using the period makes more sense than the time delta, which is specifying the minimum amount of time between time grants. Mm-hmm. And the period is specifying an interval over which you can grant.
Yeah.
But the fact that a minimum time step can still be like the use case I'm thinking of is, suppose for a normal simulation is going on, and then a switch opens or something, and then relab enters into delta mode during simulation. Would that still be covered with Helix?
Yeah, changing the time, the minimum time delta and the period during simulation is supported. There was a recent bug fix related to that, but it should be functional now.
Okay, thank you.
Yeah.
I have a question on the composite load model you're using. Is that part of InterPSS or is that part of GridLab-D?
The composite model is not part of any of this. It's the commercial tool, but what we are comparing with is the same. For example, they are only available for transmission systems, the composite load. But what we are here is so maybe it's more easily is this one. So we are comparing the result from composite load model with detailed distribution systems models.
Okay, I see.
Yeah. I try to make sure that because we don't have this measurement at the distribution level, but through this kind of a detailed simulation study, we can get a better understanding how actually distribution actually works, particularly at the low level for their protections. Any other questions? So I think I will stop here.
Okay, yeah, I'll go ahead and stop the recording.